Okay, should I repeat myself or can we just go on?
Okay, go on.
Go on Nanti saya recap balik. Okay, so tadi we talked about range and height. So at this point, the height dia cakap 0 because this is asking for the final displacement. So final displacement is here, which is x is here, from here to here, that is the displacement, whereas the displacement in the y is just 0. Displacement in y is just 0 because 0 height. And then displacement in the x is range. It's called range. So if the question asks you, what is the range of the ball? What is the range traveled by the ball? It is asking you for the final displacement in the x-axis. And to find this, you use equation S equals to ut plus 1 over 2 at squared. Here, dia dah terus substitute minus g. Okay, so a lot of you are panicking. Don't worry, we're going to look at an example. Okay, so range and height of projectile motion. So here is saying complementary values of the initial angle result in the same range. What does complementary mean? Complementary means it completes each other. Okay, bila saya cakap, oh you compliment me, maksudnya saya sukalah dia complete my life. Macam itulah. It completes each other. Okay, so for example, 75 is completed with 15 to make 90. 60 is completed by 30 to make 90. So 75 is complementary with 15. 60 is complementary with 30. So dia cakap kat sini, complementary values of the initial angle result in the same range. Okay, let's see. 75, the range is at 120 lah, for example. 15, the range is at 120 juga, so sama. And you can expect the same for 60 and 30. So what is the range for 60? If I am shooting my ball at an angle of 60 degrees, I will land at this range, which is 220, for example. If I am shooting my ball at an angle of 30 degrees, let's see, 30 degrees is here, here, I will land at the same point as when I shoot my ball at 60 degrees. Okay, so it's a fun fact. You don't have to memorize it because you will solve it anyway. So the range will be the same, but the height will be different. So 75, the height is so tall. 15 is like super low, but the range is the same. The range is the displacement in the x-axis. Okay, is everyone okay? Okay, all right. Maximum range occurs at a projection of 45. So let's see. 45 is this guy over here. So I am going 45 degrees at an angle of 45. I land here, which is the maximum range. So this is just a fun fact. You don't have to memorize it. We will just use values to solve it anyways. Okay. Let's try this together. Try this. Let the launching angle and speed be 30 degrees and 50 respectively. Find the time and height at the highest point. At the highest point. Okay. What is the first thing that you can remember when you say highest point? What happens at the highest point? Can anyone tell me?
V equals 0.
V je. V equals to 0.
Vy equal to 0.
Vy equals to 0. Yes. Thank you. Thank you to everyone yang jawab tadi. Okay, so let's try this. Find the time and height at the highest point. Okay, so acceleration in the horizontal component is 0 because gravity does not act horizontally. And in the vertical component, acceleration is minus 9.81. Okay, so initial velocity. If this guy is 50, so this is V naught, this is 50. So Ux, which is my initial velocity in the X direction, and I have an angle. So this is Ux, this is Uy. my ux component is touching the angle, so the ux gets the cosine. So this is just V naught cosine 30 degrees. Okay, and this is, let's just solve it through. So cosine of 30 degrees times with 50. So that will give me 43. Tak cukup tempat. 0.30. Okay, so that's my ux. What about my uy? Oh, kejap let me just put this in a document supaya boleh saya banyak sikit ruang nak tulis. Sekejap document 8. Okay. Alright. Okay, so let's try this again. So A, okay, so A, yeah, A equals to 0. A equals to minus 9.81. Initial velocity is ux, v naught cosine theta, which is 43.30. Uy is v naught sine theta. Betul ke? Am I doing this correctly, guys?
Yes, doctor.
Okay, just checking. So sine theta is 30. Sine 30 is 0.5 times 50. So that's a 25. So I already solved the initial just by resolving. I didn't use the kinematic equation at this point yet. My initial velocity did not have to be solved using the kinematic equation. I just resolved it. Okay. So kita dah sampai sini dah. Baru pakai resolve je. Okay, so final velocity. I told you that the final velocity for a symmetrical problem will be the same as the initial for the x component, right? So Vx, kenapa tak ditulis? What happened?
Doctor,
Yep,
I have a question.
okay.
How do we determine that 30 is
how data?
the theta and also 50 is the V naught?
Oh,
How to
because
determine it?
this is in degrees. So this is obviously the theta. Tentu ke soalan awak?
Oh ya, sorry. Saya tak nampak dia punya degree tadi.
Oh,
Thank
okay.
you.
Okay. Tengok pada ni the units. This is your V naught. And then it says let the launching angle. Okay, launching angle. So maksudnya dekat initial point lah. Dia baru nak launch. Okay. Then the final velocity is Vx equals to, we can use the V equals to U plus AT equation untuk Vx. So U is just Ux plus AT squared, which is a 0 because acceleration is 0, which gives me Vx equals to Ux, which is 43.3. And then for Vy, kalau Zoom record, dia tak record screen lah kan? Oh, tak apalah. Ni korang salin So Vy is, oh dia record lah kan? Apa dah saya cakap ni? So Vy is U plus AT, right? So this is Y and this is Y. So Uy, we already know this. This is 25. This is AY is 9.81 and T. So we can't solve for Vy because I don't know what my time is. But the question is asking me for the time and height at the highest point. So at the highest point, we know that Vy is 0, right? At highest point. Okay. So I can solve for the time at the highest point. Solve for time at highest point by using Vy equals to 0. What that means is I am going to solve t at this point. Okay, it's here, Vy is a 0. So let's do that. 0, 25 minus 9.81 t will give me a t of, I don't know, 25 divided by 9.81 is 2.55 seconds. Okay, so I already solved that. Find the time at the highest point. Yay, I got it. So the time is t equals to 2.55 seconds. This guy is also the same. At the highest point, 0. Okay, we are using this table depending on the question. So this will be the displacement at the highest point, the time interval at the highest point. At the highest point. Kalau dia tanya at the final point, then this table will not be Vy equals to 0 lah. Okay. And then displacement pula. Dia tanya find the time and the height. So it's asking you S in the Y direction. So let's do that. S in the Y direction. So S equals to UT plus 1 over 2 AT squared. Boleh juga pakai another kinematic equation if you like. So SY UT, we know that U is 25. And the time taken to reach the highest point is 2.55 seconds, which we got just now. Plus 1 over 2 minus 9.81, because gravity is still acting on it, 2.55 squared. This will give me the maximum height, which occurs at time 2.55. So that is, I don't know. Can someone calculate that for me? Saya selalu salah tekan calculator. Saya akan buat, but I'm pretty sure I'm going to get that wrong. Minus 9.81. Did you get 31.86?
Yes.
Okay.
Yes.
So 31.86 is the maximum height. So this is the height, which is the displacement in the y-axis. And it occurs at time 2.55 seconds. So we are done for part A. Any questions for me? Okay, kan? So the key thing to remember for this type of problem, where it's asking you about the highest point, is Vy equals to 0. And when we know that Vy equals to 0, we got the time, and then we could solve for the height. Okay? Okay, so I'm going to continue with the next part. So this part, part B. Oopsie. Okay, so part B. Find the time of flight. Time of flight maksudnya total time lah sampai dia habis, sampai dia drop balik. Range, which is the displacement in the x-axis, the total displacement in the x-axis. The final velocity at the landing point, which means that it's asking you the v, which is vx squared, vy squared, square root of that. Okay, so that's the v. And if they ask you for the direction, you also have to provide that. So let's just solve it for the direction and magnitude. So let's do this together again. Acceleration in the horizontal is 0. Always 0 in the horizontal component. Our A is minus 9.81. Initial velocity is, you already solved that. Sekejap, copy balik. Which is V0 cosine theta, 43.3. It's the same problem, kecuali part B. Same problem, 30 degrees, 50. 43.30, and this is the uy, just 25. And final velocity, kita dapat, oh tadi displacement, tadi dekat maximum height kan? Now the question is asking you at the end. Okay? So jawapan kat sini akan berubah. Jawapan kat sini kita buat untuk highest point. Final velocity, displacement and time interval for at the highest point. For part B, we are solving for at the end of the projectile motion. So now let's use the equation again. So final velocity is Vx ux plus at, whereby a is just a 0. So this is easy peasy. Vx is just ux or 43.3. Vy is uy plus at. Uy is 25. A is minus 9.81. I do not know the time to reach the end. I don't know yet. And then Vy, I don't know. Okay, let's just write down all the equations first. And then for displacement, my S is I'm trying to find the range, right? So that is ut plus 1 over 2 at squared, where a is just a 0. So I don't have to solve that. So I just need to know what is the time to solve for Sx, because I already know my ux. So it's just 43.3 times with the time to get the range. Okay, what about Sy? Sy at the end of the flight is just 0. Okay, and we know that ut plus 1 over 2 at squared. So let me find what is the time when Sy equals to 0. Let's just try. So we have this information, 25t plus 1 over 2 minus 9.81 t squared equals to 0. Now, if I try to solve this for t, what will I get? 5, right? 5.1. 5.09 macam tu lah. 5.1 je lah. Seconds is my t. And I told you, kita sampai dekat maximum height. The time was t 2.55 seconds. Since this is a symmetrical problem, the total time to reach displacement 0 in the y-axis is t times 2, which is 5.1 second. Penat je tulis kan? Sebenarnya senang je. But this is for your understanding. At this point, my displacement is 0. That is why I said Sy equals to 0. Let's just solve for t. And I got the total time of flight. Okay, so this is total time of flight. If you're already confident and you know the answer, just times your 2.55 by 2. You get the total flight. Okay, we know the time that it takes to reach the total flight. So what is the range? The range is Sx, right? We know the total time to reach the end point is 5.1. So now I can solve for my Xx, which is whatever that is. 43.3 times 5.1 is 220.83 meters in the x-axis. Okay, so displacement is 220 meter. Displacement in the y is just 0 because we are at ground level. There is no height, so it's 0. Time interval to reach this point is 5.1 second. Time to reach the 0 point for the y-axis, 5.1 second as well. Told you the time is the same. Find the final velocity at landing point. So have I solved for Vy? I have not. So let's do Vy now. 25 minus 9.81 times with the total time of flight, which is 5.1. This will give me times 5.1. So I got what? Minus 25, right? So I started with the 25 and I'm ending at a minus 25. Ni y axis Started with a 25, ended with a minus 25. Sama macam free fall problem. But our ux is 43, our vx is 43.3 juga in the same direction. This guy, the direction is the opposite. Kan? Dia terbalik kan? Dia jatuh. Tapi vx still going to the right, which is what the direction of ux is. So uy dengan vy is in opposite direction, ux, vx, salah sama value, sama direction juga. Okay, so now what is our velocity? It's just Pythagoras theorem. Senang je, kalau tak tahu juga, rotan diri sendiri. Vx is, apa tadi? 43.3. Oops. So 43.3, ya Allah. Abaikan tulisan buruk tu. Vy is berapa? Minus 25. The square root of that, which will give me 50. Betul tak?
Betul.
Okay, nasib baik. Direction pula. So using this equation, Pythagoras juga. Vy over Vx, which gives you inverse tangent to solve for theta. Vy is 43.3, 25. And what is the thing that I told you about this equation? It always refers to the angle always refers to, tak ingat dah? Chapter 1. X-axis, thank you. When you solve for this angle, apa dia? Ada orang cakap jawapan tapi tak dengar. Okay, so when you solve theta, it always refers to the x-axis. So kalau janganlah pandai-pandai buat dekat y macam ni salah. Wrong. Always refer to the x-axis, correct. So V angle, so whatever angle that is, I don't know. Let's calculate.
Doctor, it should be 25 over 43.3.
Oh, terbalik sorry. Thank you. What's the answer?
30.
30 So sama lah. Okay. From tadi 25 over 43.3 gives you a 30. Okay, so it gives you a 30, which is the same angle that we started with because it's a symmetrical problem. But this is for your understanding because we are not going to always have projectile motion that is symmetrical. Okay, so how would I draw this? Remember, the theta that I solve is with respect to the x-axis. So, jangan pandai-pandai letak angle dekat sini. Salah. Okay? So, your angle is... don't do that. Kenapa jadi macam highlighter pula ni? Okay, so angle kat sini Okay, so that is your theta, final theta, 30 degrees. And of course, if you are confident with yourself, you know how a projectile motion for symmetrical problem, you can just use the shortcut, okay? But it helps to know the equations, because obviously your problems will not be simple. It will be a little bit harder than this one. Okay, any questions? Any questions? No? Semua okay Still following?
Doctor, for the question part A right just now, for try this part A, the previous one,
Yep.
can I have the answer for displacement for Sx and Sy?
Displacement for Sx and Sy. Kita tak buat Oh, displacement. Okay. Kita boleh buat. Okay, let's do this. So the displacement for Sy is apa? The maximum height lah, which is 31.86. And for Sx, let's do that here. Ut plus 1 over 2 At squared, whereby A is always a 0. So U is, we know that it's 43.3. And the X at this point in time is 43.3 times the value of time here, 2.55. Okay. So that's apa? 110. 110.42 meters. So that's your answer for Sx at the highest point. So let's take a look. If this is supposed to be a symmetrical problem, our total Sx should be the double of this. So what is it? It's 220.83. Yay, we got it. So, itu je lah for this problem. Any other questions? Was that clear enough?
Dr. White,
Main kat sini.
Dr. White is double if it is the time of light.
Why is W time of light?
No, why it will be double if it kenapa
Oh.
jadi ganda dua kalau
Oh, kenapa jadi ganda dua? Okay.
I'm sorry, I'm a little bit late. I'm a little bit sluggish to understand.
Okay, so imagine, macam nak cakap?
Wait, doctor, it's because it's symmetrical, right? So the 110.42 is when it's right at the middle, right?
Yes.
Then it takes the exact same value to travel to reach the landing point, right?
Yes, betul.
Okay.
So,
Thank you, doctor.
at the highest point, we are halfway through the motion. Separuh lah jalan, separuh jalan baru. So, kalau separuh jalan, if I know that I'm 110 here, I know that I need another 110 here. Kalau saya tahu saya kat sini mengambil masa sebanyak 2.55, kat sini pun saya tahu saya kena 2.55. Sebab apa? Simetri. Simetri maksudnya samalah, kecuali opposite direction je. Kalau yep.
Apa contoh symmetrical, apa nama benda ni? Symmetrical.
Projectile motion.
Apa contoh symmetrical projectile motion ni? Contoh dia?
Kejap saya fikir.
Kalau saya kata kita baling bola.
Boleh.
Kita
Memang
baling
kita
bola
punya
ke
bola pun.
Contohnya kita baling bola ke sana. Tangan saya tu 30 darjah. So bola tu jatuh pun dia akan 30 darjah jugalah.
Betul. That is correct. Bola jatuh pun 30 darjah, betul.
Oh. Okay.
Baling bola je. It's a projectile motion. Contoh yang tak berapa nak symmetrical. Alamak, nanti saya kantoi. Kejap. Jangan duduk sini. Macam mana saya nak buat ni? Kejap. Macam mana saya nak tunjuk ni? Okay, kejap. Tak apalah, nanti saya tunjuk video tu lain kali. But basically, okay, korang pernah tengok basketball game tak? So basketball game, you have this hoop, right? Ada tak orang main basketball kat sini? Saya lupa lah. Tak ingat kelas mana yang ada atlet tu. Okay, so this is me. Okay, saya tak main basketball lah sebenarnya. So I have this basketball and I am throwing it in to the hoop lah, because that is what the game asks you to do, right? You score by putting in the ball. So this is a projectile motion. I started at a level lower than the hoop. What is the velocity when my ball touches the hoop? So that is a possible
so
problem.
dia akan jadi susah sikit lah nak kira-kira kan.
Yes, that is
So
why.
kalau nak jadikan dia senang, kita kena lompat sampai level tangan kita tu sama dengan level hoop. So dia akan jadi symmetrical, betul?
Betul. If I started, kalau saya lompat
so kalau
sia-sia,
tangan kita ada dekat sama level dengan hoop tu, dia akan jadi symmetrical. So senang sikit lah kita nak sudut,
senang nak
kelajuan
solve lah, tapi nak buatnya susah. Macam mana saya nak lompat tu? So yes, it becomes simpler lah. The problem becomes simpler when you are at the same level. But our life is not ideal. That is not always the case. So this is a form of projectile motion. Your starting point is below your end point, right? Okay, so basketball. Okay, banyak lagi contoh. Apa-apa yang baling, apa lagi? Apa lagi yang boleh shooting? Catapult. Catapult also uses projectile motion. Okay, so just know the initial velocity and the angle, you can solve for it. Okay, so that is the purpose of learning projectile motion. You can solve for a lot of motions, lot of types of motions. Okay, so let's do this non-symmetrical projectile motion now. Okay, padam dulu basketball saya ni. So, kita punya soalan. Kenapa ni? Ada orang main Zoom lah ni. Okay, so I am in a plane. I am driving a plane. No. What? I am flying a plane. Okay, so I am at the height of 100 meters. My velocity in the x direction, because I'm flying horizontally, is 40. But my velocity in the y direction is 0. This is the question, bukan saya yang buat. The plane flies at a velocity in the x direction of 40 and in the y direction of 0. So now the question asks you, find the range r before it lands here. So dia suruh cari displacement in the x-axis when the plane lands here at the end point. Time to reach the ground. What is the time taken to reach r, to reach the range? And then see the velocity when touching the ground, which is vx squared plus vy squared, square root the whole thing. Okay, so how do we start with this problem? How do we do it? What should we do? Anyone? What should I do here? What is my Vx? What is my Vx? Come on guys, we already know this one. This is the easy one. Vx. Vx is always equals to
T.
apa?
Equal to
Vx sama dengan ux.
Yes, Vx is equal to ux. Remember, your gravity only acts in the y. So your velocity in the horizontal direction doesn't change. Okay, and then Vy, we use the V equals to U plus 80. Our U is 0 plus minus 9.8 and T. We don't know what our final velocity is. We don't know our time. So let's just leave it there first. And then displacement R. Displacement R, we can use equation ut plus 1 over 2 at squared. Okay, at squared, whereby a is just a 0. So I'm left with r equals to ut, where t is the total time to reach the end point. Oh, so it's given h equals to minus 100 because I started from here. I ended at 0, right? This is y equals to 0. This is y equals to 100. So my displacement is minus 100. Why is it a minus? Can anyone tell me why is it a minus?
It goes down
downward.
Is it direction, doctor?
Dia ke bawah.
Direction, dia ke bawah, betul. If this is not intuitive for you, just use H. Change in H is always final minus initial, right? I told you when we have change, it always starts with final minus initial. So our final is a 0, our initial is a 100. So H is a minus 100. So that is what you put in here. Okay, again, it's going downwards. That is why it is a minus. But if that is not common sense to you or not intuitive enough, use this equation. Also boleh. Okay, so we know that this is the value. So let's solve for ut plus 1 over 2 at squared. So ut, that's a 0. That's easy. So 1 over 2 minus 9.81 t squared. And this is minus 100. Okay, so let's solve for that. Solving for t. Solving for t times 2 divided by 1. Square root of that will give me time as 4.5 seconds. I hope everyone got that because I'm not pretty good at calculator. Dapat tak 4.52? Did you get that? Ke saya salah tekan?
Yes.
Dapat Okay. If 4.52 seconds is what is the time taken to reach minus 100 height, which is this point, what is the time taken to reach R? What is the time taken to reach R?
4.52 seconds.
Yes, 4.52 seconds. When Y is a 0, X is an R. So it's the same time, just use it back. 40, we know U is 40. So T is, apa tadi? 4.5, 2. Okay, so that is 4.52 times 40, 180.8. So my R is 180.8. Okay, and my H is minus 100, which is given. Time is the same, 4.52 seconds. So we solve for range R, we solve time to reach the ground, velocity when touching the ground. How should I do this one? What is my velocity when touching the ground? How should I do this one? We find Vx, we already know this. Okay, and then we find Vy using what time?
Total time.
Total time, right? So that's 4.52 times minus 9.81, which gives me a negative velocity 0.34. Okay. So then, same thing, just use your Pythagoras theorem equation. Okay, and I'm pretty sure you know this one. Solve for that one as well. Okay, don't know what the answer is. I didn't do it yet. Okay, so that's an easy one. Easy lah sangat. Okay, so this one is going to be your assignment. Don't panic. I know it looks hard, but there's a video on this problem on Instagram. Please watch it. I'm going to give you a question whereby I change the values. Please take a picture of your working steps. You can do it in form of table or you can just put in your equations. I don't mind either way as long as you are comfortable. Watch the video, solve this problem and this problem. Two problems. I will give you these problems on WhatsApp. Try to do it. Take a picture of your working steps and then upload it on Putra Blast. I will let you know on how to upload it. Don't worry, it's not soon. I think next week. Next week I'll ask you for the jawapan. You can discuss as usual. Okay, so that is going to be your assignment. This one is the same as the plane. Can anyone tell me why this is the same as the plane problem?
Sebab Dia terus ke bawah, dia tak naik atas dulu.
Betul. So your plane has apa tadi? Ux value but 0 in the y direction. So the uy is 0. Okay, so it goes this way instead of upwards, right? So it goes here, terus ke bawah. There's no angle ke atas. So terus ke bawah. Okay, so it's the same problem as the plane. Yep, ada question? Kalau soalan yang saya kasih assignment tu ada angle. So that's the
So kena
difference.
tolak displacement symmetrical tu dulu lah.
Tolak. Boleh? Boleh. You can try that approach. Either way, asalkan boleh solve. Okay? So just take a look at the video first before you attempt. Okay, so this part, displacement time graph, etc., velocity time graph, I will do a video on this and I will give you the video because this part is quite easy. Sebenarnya saya boleh je suruh nak belajar sendiri, but I know that's not, saya tak percayalah awak nak belajar sendiri. So saya akan buat video. Okay? So this one, I will give you a video later. Okay, and then there's an assignment on this part and this part. Okay. So now we're going to go into chapter 3 because we are running late. So new about the recent chapter 3. Okay. So before I start on chapter 3, any questions on chapter 2 apart from the assignment and the video?
Doctor, after we find Vx and Vy, we have to use the formula to calculate the V.
Yes.
Okay, thank you, Doctor.
Okay. Any other questions? Okay Kenapa participants kita sikit Ada 33 je termasuk Izul dengan Zul Hakim. So ada 34. Where is the rest?
Dr. Humaira is sharing with me.
Oh, Humaira is sharing.
with me.
Okay.
Amir Yusof.
Okay, so 1, 2, 3.
Dr. Amanina is sharing with me.
Oh, ada juga. Okay, cukup lah. 37. Kelas korang 37 kan?
Amir lagi.
Apa? Crying?
Amir Yusof.
Kenapa?
Amir Yusof.
Crying?
No, sharing with me.
Oh, sharing. Saya buat dengar crying. Kenapa crying? Okay. Okay, let's start with chapter 3. I'm glad everyone's here. Okay. So for this chapter, so I told you chapter 2 is a little bit harder than chapter 1, and we use the vectors that we learned in chapter 1 in chapter 2. So we are going to use the things that we learned in chapter 2 in chapter 3 now. So it gets a little bit harder lah, but okay je. Okay, so for chapter 3, force and motion, we will learn on inertia and momentum, Newton's law of motion, forces on an object, object in equilibrium, and object in linear motion. So this chapter is a lot more interesting, but personally I like projectile motion the best. But this one is interesting juga. But some people says it's more interesting because it's a lot harder. Okay, just kidding. Okay, so learning outcomes, define inertia, mass, and momentum, state the Newton's law of motion, identify forces acting on an object, and sketch its free body diagram. Okay, I'm not gonna curse. What is free body diagram? This is very crucial. Kena belajar lukis free body diagram. Kalau salah lukis free body diagram, you cannot solve the problem at all. Free body diagram is crucial. So belajar betul-betul free body diagram ni. Pakai sampai SEM 2. Apply Newton's law of motion and solve problems on objects in equilibrium. Okay, tak apa, nanti kita tengok. Apply Newton's law of motion and solve problems related to object in linear motion. Okay, so learning outcomes is in your book. This highlights what you need to study for your exam. Okay. Okay, so what is inertia? Inertia is the natural tendency of an object to continue its state of motion. For example, if my state of motion is at rest, I am sleeping. How can I wake up? I can wake up if Amirul Alif wakes me up. he uses force to wake me up. So daripada rest, ada force datang, so saya bangun. So if Amirul Alif tak datang, saya continue tidur lah. And then if I am moving on a bike at a velocity of 25, unless someone comes and pushes me, my velocity stays the same, neglecting air resistance. My velocity stays the same unless someone comes and stops me, or someone comes and pulls me, or someone pushes me. And push and pull is a force. So if there's a force, then baru motion tu berubah. Kalau force tak ada, motion tu kekal. Okay. So this is the first law of Newton, Newton's first law, which is the law of inertia. You continue to be in your motion unless there's a force acting on you. Okay? Force is F. Okay, so object at rest. You need a force to move a stationary object. Tengah tidur, ada orang kena kejut baru bangun. Object in motion, tengah jalan, ada orang stop, ada orang tarik, ada orang tolak, baru kita punya velocity berubah. Okay, tu contoh. Mass. You need a force to move a stationary object. Okay, obviously, it is more difficult to move a heavy object as compared to a lighter one. Why? Let's write this. Masuk sini balik. Okay, draw. So remember, F equals to ma. You already learned this, like way back. When you have a bigger mass, which means that your force needs to be bigger. If your mass is smaller, your force is also smaller. So it is more difficult to move a heavy object, which means that you need more force to move a heavy object as compared to a lighter one. Inertia is the natural tendency of an object to remain at rest or in constant velocity. Okay. Lupa nak tambah ni. Lepas tu, the amount of force needed to overcome the inertia depends on the amount of particles contained by the object. Okay, ni macam complicated sangat. Kita tak cover dalam syllabus ni. It is measured by the mass of the object. Okay, we will take a look at this part later. Coming into momentum. For an object in motion, there is a natural tendency for an object to remain at a constant velocity. Okay, we know this. It is more difficult to make such change for heavy object compared to lighter one. Kenapa macam sama ni? It is more difficult to make such change for a fast moving object as compared to a slow one. Tadi kita cakap pasal heavy versus light because F equals to ma. It is more difficult to make such change for a fast moving object as compared to a lower one, which is momentum lah. The quantity that measures the inertia is the momentum of the object. So this sentence relates to momentum. Momentum tinggi is when your V is tinggi. Momentum tinggi is when your mass is tinggi. Vice versa. So bila V tinggi, mass tinggi jadi susah. The force required to stop or change is going to be greater lah. Okay, so momentum is P equals to mv. Tada! I already said about mass, already talked about velocity. Sebenarnya P equals to mv, where P is momentum. Momentum is a vector because when you multiply a scalar quantity, which is a mass, with a vector quantity, which is your velocity, you will get a vector quantity, which is your momentum. And the unit is kilogram, velocity, meter per second. Okay, mass per second, meter per second is your velocity, kilogram is your mass. That's your SI units. Next, Newton's first law, an object will remain at rest or moves with constant velocity that is constant in magnitude and direction unless acted on by a force. This is our inertia thingy that we talked about just now, also known as law of inertia. So that's the first law that you need to remember. Newton's second law. What is the relationship between mana pergi ni? Mau saya. What is the relationship between force with momentum? All moving objects has momentum. We need force to change its velocity. Okay, tak apalah, tak payah baca. Tengok equation terus. So let's take a look at this. Newton's second law. The rate of change of momentum of an object is directly proportional to the force acting on it. Again, the rate of change of momentum. Okay, what is change of momentum? Delta P. Kita tahu P itu momentum. Change is given by delta or the triangle thingy. Rate of is always over delta T of an object is directly proportional. Proportional is like this to the force acting on it. Proportional to force. So this is how we get this equation. And dia cakap, okay, so it's directly proportional. Is there any other elements involved? For this syllabus, no. So let's just say F equals to delta P over delta T. Okay, so force is equal to the rate of change of momentum. Rate of change of momentum. Okay. Next slide. But momentum is P equals to mv, kan? Kita dah belajar ni tadi. Equation P equals to mv. F equals to delta P over delta T. Sama je, you can write it as dP dt. And if I were to put this in my P, it becomes d dt mv. And expanding this gives me m dv dt plus v dm dt. This is just maths. Okay. This is not a maths class. So if you want to learn how to derive this, you can belajar maths lah. Pergi belajar differentiation. Good. If m is constant, then delta m change is constant, zero lah kan. Again, if m is constant, the change in mass is zero. Okay, this is common sense. If mass is constant, there's no change involved. The change is zero, which means that this guy, the change in mass over the change in time is zero, which gives us m dv dt je. Kan? Equation ni mula-mula macam ni. Lepas tu kita cakap, what if mass is constant? Kalau mass constant, maksudnya dm dt kosong. So kita left with just this guy. And kita tahu dv dt ni A, because its acceleration is the rate of change of velocity. So we have F equals to ma. This equation is only true if the mass is constant. Any questions so far? Is everyone okay? Okay, continue. Next, what if my, okay, dia cakap pasal SI unit dulu. The force on 1 kg of mass to accelerate 1 meter, to accelerate at 1 meter per second squared is Newton. Okay, Newton to accelerate 1 kilogram of mass at an acceleration of 1 meter per second squared. That is the definition of force or Newton lah. Newton lah basically. Okay. What if there is a change in mass? Tadi kita cakap delta M sama dengan kosong kan? Now delta M ada value. So maksudnya equation tadi tak bolehlah kita pangkah kosong. So it's there. And we know that dv dt is just A. So this equation becomes F equals to ma plus v dm dt. This is when mass is not constant. Oopsie. Mass not constant. Okay. Oh, dah tulis kat bawah tu. Sorry, tak perasan. Okay, so that is Newton's second law. F equals to ma if mass is constant. If mass is not constant, you have this equation, ma plus v dm dt. Momentum is P equals to mv. Newton's third law. First law was law of inertia. Second law was F equals to ma. Third law, if object 1 and object 2 interact, the force exerted by object 1 on object 2 is equal in magnitude but opposite in direction. Sama magnitude sama, direction lain. So, let's say I am Nadia, that's my name. I am on the ground. Okay, saya pakai skirt. So, I have a force, which is my weight, right? Weight is just mass times gravity. Sorry, itulah gravity acceleration kan, which is 9.81, right? So this value is rahsia. So weight, saya pun rahsia lah. Okay, so this is the magnitude of my weight. The direction is going down. So this is, let me just label this as F0. Okay, so I am on the ground. The ground is object 2. I am object 1. Object 1 exerts a force on object 2, which is the ground. Object 2 says, hey, suka hati kau je duduk atas aku. So object 2 retaliates, dia rebel. So what happens is, object 2 is going to push me in the same magnitude but in the opposite direction. So object 2F, this is object 1, right? The F for object 2, kenapa lah pakai hijau? So the F for object 2 is just minus F0. Tadi saya punya force is F0. Force exerted by the ground on me is minus F0. Okay, saya cakap going down is positive F0. Saya cakap je lah, so I define sendiri. So object 2 punya force acting on me because its opposite direction is upwards, it's negative F0. Okay, so macam tu je lah kot. Okay, so if we have a brick and a table, the brick becomes object 1 and the table becomes object 2. Boleh je reverse eh? Tapi object 1 is applying force on object 2 because it is on top of the table. It is applying its weight on the table. So whatever the weight is, F12 is exerted downwards. The table says, hey, don't do that, it hurts. So dia cakap, okay lah, I'm going to exert an equal force in the opposite direction. So that is your F21. So F12 is the same as F21, but the direction is different. That is why they switch the numbers here, which is the same as minus F12. Okay, I hope that's clear. Newton's third law, equal magnitude, opposite direction. Tu je. When there's two object interacting, equal magnitude in force, opposite direction. Okay. Any questions so far? Okay, eh? All right. So we have anyone? Okay. We have external forces and internal forces. External forces, for example, push and pull. I have a bottle, I am pushing it. I have a bottle and I'm pulling it from my hand. That's external force, you can see it. Internal force, such as vibrations of the molecule of water inside this bottle. I can't see it, but there's something going on inside this water, which is the vibration of water molecules, which is not available for us to see because it's internal. Okay, any internal reaction. For example, nuclear force, weak forces. Usually internal forces weak lah because benda yang kita tak nampak. Kalau kita nampak maksudnya dia dah huge lah kan. Vibration of atoms, which is weak force. Okay, so we have tadi external and internal. Now we have contact forces versus non-contact forces. So contact forces, maksud dia seperti yang nama dia suggest. We have to be in contact. I have to be in contact with this bottle for me to pull it. I have to be in contact with this bottle for me to push it. Sama juga macam I'm applying to this string. Sama juga when I'm applying pulling direction to this card and to kick the ball, I am also applying a force for contact. Kalau saya tak contact dengan ball, the ball tak akan bergerak lah. Tak boleh lah nak sepak ball. Okay. And then we have non-contact forces, which is also known as field forces. This is gravitational force, which gives us gravitational field. This is the smaller mass. This is the bigger mass. For example, this is the Earth. This is the Sun. Okay, we know that there's gravitational force going on that gives us our gravity and stuff like that. And then we have electrostatic force, which is electrostatic. Apa example? Tak nak fikir pula sekarang. And then we have magnetic force, which is magnet lah. Okay, so it doesn't have to be in contact. Dari jauh pun boleh rasa the magnetic force. Let's say I am an iron and there's a magnet over there. I can already feel the magnet trying to pull me, even though the magnet is not in contact with me. So that's a field force. or a non-contact force. Saya rasa tertarik dengan magnet tu. Cik, macam ayat nak pick up line pula. Okay, so forces on an object. We have gravitational force, normal reaction force, frictional force, tension of a spring, which we will look at closely, don't worry, and other direct contact force. Okay. Gravitational force, which is what gives us our weight. Gravitational force is a field force. Okay, gravity is from gravitational force lah. And there's a special equation used to calculate F equals to G, bigger mass, smaller mass, and the radius between these two masses, or Earth and Sun. For an object, or Earth and Moon. For an object at height h above the Earth, the radius is added to the h. Okay, this is to elaborate. We will learn this in semester 2. But know that your A equals to minus 9.81 comes from this equation. So F equals to mg comes from this equation. So your weight is from this guy. Okay, this weight. This is the equation that you get, that you need to find weight. But they simplified it for you. So they said, okay, let's just say F equals to mg, where g is 9.81, because I already done the math for you. Okay, I simplified things. You only need to know your mass. Okay, so that's weight. So weight is labeled as mg, or w, or fg. Either way it's fine, but fg or weight is equal to mg, where m is the mass, g is the acceleration due to gravity, or 9.81. Okay. So that's the first one was gravitational force, right? The second one is normal force, which is actually the third law, Newton's third law equation, which is it's equal in magnitude but in opposite direction. Normal reaction force always exists when two objects are in contact. So it's a contact force. Kalau tak ada contact, tak ada normal. Saya on the ground. Contact, yes. Normal force ada. So I label reaction R. It's labeled as R. So the R is this way. Okay, what if I am flying? Because I am Superman. Okay. Contact? Zero contact. No. So R pun tak ada. No R. R only happens when you are in contact with something. Okay. And then the direction of normal force, or R, is always perpendicular to the surface. Perpendicular maksudnya 90 degrees. Okay. Kalau kereta ni in contact dengan road, the R is 90 degrees to the road, to the thing that you are in contact with. The car is in contact with the road, which means that the R is 90 degrees to the road. Okay, ni road, R is 90 degrees. Any table, R is 90 degrees. This is me, R is 90 degrees to the ground. Okay, so that's your normal force. Okay, so here we take a look at examples of normal force. So this is a box on a table. The box has Fg equals to mg. Ya Allah, gambar dia teruk sangat. F equals to mg, which is the weight. And again, Newton's third law says if there is a force acting, if there's two objects interacting, object 1 is applying some force, so object 2 will apply the same force but in the opposite direction, which is R. Okay, and then I am pushing a box to the wall. The reaction force is 90 degrees to the wall. And my force is this way lah, sebab I'm pushing. Okay, so R is equal but in opposite direction. Any questions for me so far? Okay, Yep.
Doctor, is it normal force is always as a symbol R?
Saya kadang-kadang saya tulis N pun boleh juga. So it's either R or N.
Thank you, Doctor.
Okay. Okay, so next one, normal force if we have a slanting. We have a, panggil apa ni? What do you call this? Forgot. If we have a slanted road, for example.
An inclined plane, Doctor.
Oh yes, inclined plane, thank you. If we have an inclined plane, so weight, remember gravity always acts in the x-axis. Okay, so G equals to 9.81 going down, which means that our F equals to mg is in this direction, right? So this box punya weight is not like this. No, it is like this. Macam ni Allah, saya ingat juga. Sekejap So F equals to mg is like this. Okay, weight equals to mg or F equals to fg equals to mg. Boleh. So weight equals to mg is in that direction. I cannot stress this enough. I always see people drawing this way as weight. Salah Weight is dependent on gravity. Gravity always goes down. Macam mana dia nak sengit pula tiba-tiba? So it always goes down. Okay. That's your first one. And then how do we solve for the normal or the R force or the N force? Let's just use R. Okay, so we have an angle here, theta. So I can actually say, if theta is here, I can say this is also theta. Okay, so this is also theta. If this is theta over here, which means that in this direction, mg cosine theta, because this is the component touching the angle. And at this point, mg sine theta. Now, what is my R? What is my R? R is always perpendicular to the surface. What is my R? Anyone? R is always equal but opposite direction.
Negative mg cos theta.
Correct, but it's not negative, right? It's just mg cosine theta in the upward direction. I didn't label this as negative because I already labeled this downward. Okay, faham tak? Because I already showed you the direction, I'm just giving you the magnitude here, which is mg cosine theta. So the magnitude of my R is mg cosine theta, but the direction is the opposite of my mg cosine theta that I resolved bawah tadi. Okay, so this guy is in this direction. My R is in this direction. It's the opposite direction, but same magnitude. Newton's third law, equal but opposite direction. Okay, so remember, if you have a theta here, your angle is here. Draw this. So the free body diagram should have the W equals to mg, the mg cosine theta, the mg sine theta, and the R. Okay, let's take a look at another example. Oh, belum example lagi. Sekarang force of friction. Okay, when an object is in motion or tends to move on a surface or through a viscous medium macam gel lah kot. Saya nak cakap, ada lalat dalam gel, susah kan nak jalan kan? Dia banyak friction. Apa friction bahasa Melayu?
Geseran, Doktor.
Geseran Okay, thank you. Geseran, banyak geseran in the gel. Whereas in the water, lalat tu senang je berenang. So, this is through a viscous medium lah. So, when you have a more viscous medium, such as a gel versus a water, there's more friction involved. Okay, and then there will be resistance to the motion. This is due to the interaction between the object and its environment. This resistance is called friction. Okay, I know we said we're going to neglect air resistance, but friction due to surface, we are going to account for that for. Friction due to surface tu tau. Okay. So direction of friction is always opposite. The key thing to remember, always opposite. Tadi normal opposite direction juga kan, but equal. Direction of friction is always opposite. Did it say equal? No, it didn't say it's equal. So what is it? What is the magnitude of friction? Direction of friction is always opposite to the direction of motion. If I am driving a car, this is my car. Macam biasalah buruk. Lepas tu ke kanan. This is direction of my car, V. So my friction is the opposite direction. So F is here. If I am going this way, my car is tengah turun bukit, right? This way, friction pun arah yang sama tapi terbalik. Arah yang sama, axis yang sama tapi terbalik. So axis yang sama tapi terbalik dengan motion. Okay. So it depends on how the motion is. Kalau tengah naik atas, naik bukit tinggi, so the friction is the opposite direction. Okay, so how do we find the magnitude? The equation of friction is mu r. How do you pronounce this? Mu. Mu. Or mu. I don't know how to spell it, but that's how you pronounce it. Mu. Mu r. Okay, what is r? Normal force. So susah tak nak cari? Senang je, tapi buat complicated sikit lah. Macam on an inclined plane, we know that r is ada kena resolve mg, cosine theta, blah blah blah. What is mu? Mu is the constant. It depends on the surface of what you are traveling on. Let's take a look at mu. What is mu? Okay, so we have coefficient. Coefficient ni mu lah. Coefficient of static friction, coefficient of kinetic friction. The values are different when your object is static, maksudnya tak bergerak. The value is different when your object is moving. Okay, I don't know why, but it's different. So wood on wood, geseran yang berlaku, the friction that is needed, the coefficient of friction that is needed to make it stay is 0.4, and the coefficient when it starts to move is 0.2. So it decreases when it starts to move, the friction decreases. Let's see, eyes on eye, 0.1 when it's static, 0.03 when it moves. Metal on metal, 0.15, and then it decreases when it moves. Okay, so different surfaces have different coefficient or different mu's. This table will be given if needed. The values of coefficient will be given to you lah. You don't have to memorize. Okay, so static friction acts to prevent an object from starting to move, whereas kinetic friction tries to slow down. Okay, you know that geseran akan melambatkan. So kinetic friction tries to oppose the motion or slow down. Okay, tulis dah. Static friction prevents the object from moving. For example, I have a box on an inclined plane. How does it not move? Dia tak bergerak. Macam mana dia boleh tak bergerak? Because we have static friction. Yes, we have static friction that holds the box from moving downwards. But in reality, if we make this surface slippery by putting in water, it goes down because now the coefficient is small. So the friction force is also small, so it cannot hold the weight of the box. So it falls down, the box falls. Okay. So static friction prevents the object from moving. Kinetic friction opposes the motion, makes it slow down. Okay, so let's take a look at static friction. When static friction is greater than F down, when F static is greater than F down, apa yang nak cakap ni? As theta increases, F static decreases. F down increases. Okay. And the equation for F static is mu S R. So to differentiate between static friction and kinetic friction, it's mu S versus mu R. So F static, You can also write it as small f s, mu s r. If it's kinetic, fk, mu k r. Okay, so the difference is in the mu, the coefficient. The r is the same, so you always need to solve for r. Okay, so as theta increases, okay, imagine the inclined plane. As I increase the angle, f static decreases. F static decreases, F down increases. At the point where F static equals to F down, that is the limit to where the box will start to move lah. Dia sebelum dia bergerak. When F down is greater than F static, that is when your box starts to move down. Let's take a look at an example. Ada tak? What time is it? Oh, 4 minutes to go. Oh, I think I should explain this next time. Okay, any questions before we end class? Any questions for me? Next class we'll cover on static friction.
Doctor? Sorry, I just wanted to clarify again. For the example earlier, right, when we calculated normal reaction force to equal to weight cos theta, then we don't put it as negative, even though it's in the opposite direction.
Yes, because kita lukis arrow untuk define the direction. We only put mg cosine theta as the magnitude. But if you want to put the negative, it's fine. But you have to remember lah. For me, I just like to put in the magnitude. And for free body diagram, you always have arrows. So it's actually not needed to put in negative or positive. For example, I already know this is going up. What is this? Mg cosine theta. I know this is going down. So I don't have to say negative mg. I don't have to say that because I already see an arrow going down. So I don't have to say the negative. I just have to clarify what is the magnitude. Does that make sense?
Doctor, that means the sign now, we don't need to depend on the sign to indicate direction lah. The arrow already indicate the direction, right? Is that why?
Yes, correct.
Okay.
For
Thank you,
your
Doctor.
free body diagram. Untuk equation, kita akan discuss lain. Okay? Ni free body diagram baru tau. Is that okay?
Yep, thank you, Doctor.
Okay. Any other questions? For your free body diagram, the direction is given by the arrow, but the magnitude is, the mg cosine theta or the mg is just the magnitude. I don't put a positive or a negative because we will deal with that later in the equation. Okay? Because we have a lot of axes. Kadang-kadang it's not even a y, it has an angle. Kadang it's not even an x, there is an angle to it. So what we do is we draw out the arrows, put in the magnitude, and decide whether we want to make it positive or negative in the equation later. Okay, we will talk on that later. Any other questions? Is everyone going to be okay? Anyone confused? Lost? Sad? Okay, I'm going to stop sharing my screen. Everyone okay ke sleeping ni? It's okay not to be okay.
Allah, okay.
Okay. Okay, so I will see you on Thursday. Thursday? Kan? Thursday kan? Okay. So I'll see you later. Have a great rest of the day. Bye.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Dari kata
Thank you, Doctor.
Thank you. You're welcome. Okay, bye.